Okay, so today we're dealing with vertex form of a quadratic function. We're going to graph using vertex form, and we're going to identify the transformations. Vertex form of any kind of function deals with transformations and how I move my graph around my coordinate plane. So if I move it up, down, right, left, if I stretch it or shrink it. Okay, so we're going to talk about those things. So first, before we do that, we want to just go over the basics of a parabola. Okay, a parabola is the graph of a quadratic equation. It's that U shape that we see right here. Okay, this is the parent function, which is just y equals x squared. Okay. The axis of symmetry is the line that goes through the vertex and cuts the parabola into two equal parts. So if you see this blue line here, if I fold my parabola on that blue line, it would be equal on both sides. They would overlap. It has symmetry, which is why it's called the axis of symmetry. It is always x equals. X equals whatever the vertex, the x value of the vertex. So in this case, my vertex is 0, 0. So the axis of symmetry is x equals 0. Yes. This is your homework. Where's your notes packet?
I just have one.
The vertex is the maximum point. Or the minimum. Of the parabola. Okay, so the maximum is going to be the highest point. The maximum is the vertex. When the parabola faces down. Okay, because when it faces down, that's going to be the highest point your parabola will go. The minimum is the vertex when the parabola faces up. because now the vertex will be the lowest place it goes. Any questions over that? Okay, parabolic shapes are everywhere. Okay, if you've seen a bridge, the cable wires are usually shaped as like a parabola. Rainbows. Are parabolas. Yes, the McDonald's sign has 2 of them. Okay. The letter U. Okay, an umbrella. There's a 10. So those are the way you see it. I'm gonna put dot, dot, dot. Okay, what situations can be modeled by a quadratic function? Okay, once we kind of apply the math, the quadratics, okay, any type of throwing of an object is going to follow a parabolic path. Okay, it also can be modeled using the quadratic equation. Okay. Throwing or kicking a ball. In football, if you kick a field goal, it follows that shape. Yes. Do you? You kick the field goals, or you're a punter? I do everything. You do everything? Very cool. Good job. Did you play soccer? Most of them come from soccer. Okay. So then you could analyze your kicks by coming up with the quadratic formula for the distance that it's traveling, how high it'll go. Okay. Yes. Yes, the swing that follows that path too, and probably could be modeled. That'd be interesting though, because it would be probably one velocity in each direction. So it'd be 2 different equations as it's going back and forth. Yep.
I was going to ask, what is a graph? Like, what situation does a parabola with a minimum have? And I guess that's
A minimum, yeah. You don't see the minimums as much. They're mostly maximums. Okay. Any other questions? Okay. So just to review, we want to make sure we know how to identify the vertex and the axis of symmetry. So here is our vertex. Remember, the x goes first, then the y value. So the vertex here is 3, 1. The axis of symmetry goes right through that vertex and is a vertical line. And it will always be x equals whatever the x value of your vertex is. Any questions over that? Yes?
the parabola is only up and down.
Parabolas can go right and left. We won't do them this year. We won't have them going right and left. This year we'll only deal with them going up and down. But they can go right and left. And it would be if you notice we have, let's see all of our equations. All of our equations are f of x equals x plus 4. One that would go right and left is if x equals y minus 4 or plus 4 squared. That would be a right and left opening. But we're not going to deal with those right now. Okay. Okay, let's go on. We're going to skip this part. We don't need this. So I'm going to go right here. You can use Desmos.com. Shh, quiet down, please. Quiet, please. Okay, if you don't have a graphing calculator, you can use Desmos.com to graph anything. Okay. Here we're going to just get an idea of what do we think is going to happen if I add 4 to the length of the side of a square. What's going to happen to the graph? How is that going to change the basic graph of a parabola? Anyone have an idea of what's going to happen if I add 4? You think it's going to go up? Okay, anyone else have an idea? It's going to get wider. Okay, let's look at, I have Desmos. Okay, so this is my parent function, just the basic y equals x squared. Okay, we want to see what's going to happen to it if I add 4 inside those parentheses. Okay, so this is where it started, and now this is my new, what happened to it? Moved where? To the left. How many units? 4 units. So we're going to graph that. The width of it didn't change. Just where the vertex was. So now instead of being at 0, 0, it's at -4 and 0. And so what happened to it? It moved to the left 4. Okay, so if adding 4 to the length of the sides inside the parentheses made it move to the left 4, what do we think is going to be adding 4 just to the area? We take the area, then add 4 to it. What's going to happen? What do you think is going to happen? You think it's going to go down 4? Yeah? You think it's going to go up 4? Anyone else? Okay, so let's go back to our graph. Okay, it went up 4, right? Did the width change at all? No, same width. So now I'm here at 4. So this went up 4. Any questions over that? Okay, what do you think is going to happen if I multiply the area by 2? You think it's going to get skinnier? Okay, anyone else have an idea? What do you think it's going to happen? Yeah? Get squished down? Okay, let's see. Okay, so remember the red one was our original graph. This is y equals 2x squared. So it got thinner. Okay. So my vertex is still at 0, 0. But instead of moving up, one and over, it goes up 2 and over. So it looks kind of like that. It got thinner. Any questions over that? Okay, so what happens if I take half of the area? It's gonna get wider. Okay. Let's see. And it did. It got wider. So again, the vertex is still here. It just goes up slower. So it got fatter. Okay, we should already know this, but what do you think is going to happen if I make it negative? Very good. It's going to be upside down. It's going to face down. We kind of talked about this in our last set of notes. This is what we call reflecting across the x-axis. It reflects across the x-axis. Any questions over that? Okay, we're gonna look at our equation in vertex form and describe all of the transformations that it can occur based on what my equation looks like. This is something that will follow you as you continue on in math. These transformations are the same for any type of function. For a radical function, for a exponential function, for polynomial functions that you'll learn next year, logarithmic functions that you'll learn next year. Okay, all of these. Yes? Oh, it didn't copy on the back? Let's put that one out. Okay, so if my A is negative, if I have a negative A, then it reflects across the x-axis. That means it's going to face down. Okay. If the A is negative, then it reflects across the x-axis. If our A, the absolute value of A, is greater than 1, if it's 2 or 3, my graph is going to get thinner, and we call that a stretch, a vertical stretch. So I'm taking my graph and pulling it up so it gets thinner. Then if my A is in between 0 and 1, what numbers are in between 0 and 1? A half, fraction, right? Decimals, right? Yes. So this is a fraction. Then this is a vertical shrink. Okay, so you're pushing it down vertically so it gets wider. Any questions over that? Okay, now H is in those parentheses. And just like in 3-2, those parentheses means you had to change the sign. It's the same thing. The negative H doesn't move to the left, it moves the opposite of that, which would be to the right. So if the H is negative, it's going to move to the right. If it's a positive H, then it moves to the left. Okay, it's the opposite. Does that make sense? Anytime you have your parentheses, sorry about that. It's the opposite. The K doesn't change at all. The K is just as it is. It's the positive K. It's the Y value, so it moves up and down. Negative K will move down. Any questions over that? Okay, so if we look at our equation here, negative, f of x equals negative, the absolute value of x minus 1 squared plus the 3, parentheses, sorry, that was f of x equals negative x minus 1, the whole thing squared, plus 3. The negative tells me it's going to face down out front. The negative 1 tells me my vertex is going to move to the right 1. And the 3 tells me that my graph is going to move up 3. The vertex then is negative 1, but I have to change the sign to a positive 1. And positive 3. Remember, in the parentheses, I have to change the sign. So I'm going to graph where x is 1 and y is 3, which is right here. Then my axis of symmetry is always x equals, and it's whatever that value is of the vertex for the x value. So this is my axis of symmetry. Any questions over that? Then we want to find the a value. Can anyone raise their hand and tell me what the a value is? Yeah. Negative 1. My a value is negative 1. Since there's not a number there, we write in the negative, the 1. So this isn't stretching or shrinking at all. It's just reflecting because it's negative. Now to graph this, oh, is this going to open up or down, you guys? It's going to open down because it's negative. Remember, the negative tells me it's opening down. Then to find the next key points to find out how wide your parabola is, the first step is a over 1. So it's negative 1. So that means it's going down 1. And then you're going to do right and left 1. And it's always right and left 1. You'll never go right and left 2 or 3. It's always right and left 1. So from this point, I'm going to go to the right 1, and then I'm going to go down 1. Then I'm going to go to the right 1 and down 1, or to the left 1 and down 1. Okay. But this is not a linear equation, so I'm not going to repeat that pattern over and over again, because it's not a constant rate of change. This has a patterned rate of change. So the first time you go right and left 1, and then down 1, the next time you're going to go from that point, right and left, and then 3 times A. So it's going to be 3 times -1 over the right and left 1. So this is going to be -3, so down 3, and again, right and left, always 1. So I'm going to the right 1 and then down 1, 2, 3. To the left 1 and down 1, 2, 3. If I wanted to keep going, the next one would be 5A over 1. So it'd be 5 times -1 over 1, which is down 5, right and left 1. So from this one, I'm going to go to the right 1 and then down 1, 2, 3, 4, 5. To the left 1 and then down 1, 2, 3, 4, 5. Anyone know what the next step would be? 7. I'm not going to have room to put 7 on here, but it would be 7. Then 9, then 11. That is the patterned rate of change that a parabola has. So then we just connect those dots. And this is my parabola. Okay. Any questions over that? Okay, is this vertex a maximum or minimum? Maximum. Okay, we want to look for the x-intercepts. They're like right here and here. They're not like 5 or 7. It's kind of in between. It's going to be like a decimal. So this one looks like it's in between 2 and 3. So maybe like it's closer to 3. So I'm going to put 2.75 and 0. This is my guess based on the graph. I don't know for sure. And then this other one is kind of at -1, not exactly on it. So I'm going to say -0.75 and 0. Again, this isn't about, I don't know exactly. Eventually we'll solve for exactness. Right now we're just kind of getting an idea. Any questions over that? Okay, let's try this next one. Okay, we want to start with the vertex. Everyone write down the vertex for me. Okay, Brooke, what'd you get for the vertex? Very good, 2 and -3. Remember, you change the sign. So it's a +2 and a -3. So we go where x is +2 and y is -3, which is right here. Chloe, what would be the axis of symmetry? X equals 2. Can someone raise their hand and tell me my A value? Yep. The A value is the number in front of the parentheses, not inside the parentheses. Is it in front? What number's right in front there?
Oh, 1.
1. Since there's nothing there, it's a 1. So A equals 1. Any questions over that? Now again, we have a patterned rate of change. So it's going to be A over 1 is my first step. Then 3A over 1 is my second step. Then 5A over 1. So I have a 1. So this is going to go up 1. And then right and left 1. So I'm going to go to the right 1 and up 1. To the left 1 and up 1. Then 3 times 1 over 1 gives me 3, and then right and left 1. So from this point, I'm going to go to the right 1 and then up 1, 2, 3. Right and then up 1, 2, 3. Then we'll do it one more time. It'll be 5A, 5 times 1 over 1, which would be up 5, and then right and left 1. Right and up 1, 2, 3, 4, 5. Left 1, 2, 3, 4, 5. Okay, then we connect those dots. And that's my parabola. I'm just waiting to get back. Okay, you guys think you do the next one on your own? In your pairs, try the next one. So our vertex here should be -1 and -4. Change that sign. The axis of symmetry then is x equals -1. The A value is 2. So our patterned rate of change is A over 1, 3A over 1, then 5A over 1. So it's going to start with 2, and we're moving up because it's positive, and then right and left 1. So from this point, I'm going to go to the right 1 and then up 1, 2, put a dot there. I'm going to go to the right or to the left and go up 1, 2, put a dot there. The next one will be 3 times the 2 over 1. So it's 6 and 1. So I'm going to go to the right 1 and up 1, 2, 3, 4, 5, 6. Over and up 1, 2, 3, 4, 5, 6. And then this is my parabola. I can't do the 5A because it's going to go off my graph. I can't count up 10 more, so we can just do those two. Any questions over that? Okay. Let's do the next one. Okay, the vertex is going to be hard here because there's no parentheses. Since there's no parentheses with the x, what is the x value? What is it? 0. This is like 2 times x minus 0 squared minus 5. And then the negative 5 is the k value. So this graph is moving right and left none, but down 5. So I'm going to start at 0 and move down 5 right here. My axis of symmetry then is just x equals 0. So it goes right through the y-axis. Then my a value is 2. So it's a over 1, then 3a over 1, then 5a over 1. So I'm going to go up 2 and right and left 1. So the right 1, up 2. Left 1, up 2. Then 3 times 2. So I'm going to go right and left 1. And then up 6. So to the right 1 and up 1, 2, 3, 4, 5, 6. So left 1 and up 1, 2, 3, 4, 5, 6. And this is my beautiful, oh, I missed it. Try that again. This is my parabola. Any questions over that? Okay, next one. Jay, what is my vertex here? One and negative 3. It's all right. I go where x is 1 and y is negative 3, right here. So my axis of symmetry will be x equals 1. Okay, this is a little tricky because my a value is what, class? Yes, a equals 1/2. It is still a over 1. 3a over 1. And then 5a over 1. So in this case, it's 1/2. Sorry, where is that? It's positive, so it's up 1/2 and still right and left 1. So from here, I go to the right 1 and up 1/2. So it's in between. Left 1, up 1/2. Okay. The next one is 3 times 1/2 over 1. What's half of 3? 1.5, 1.5, however you want to put it. If you're not sure, plug it into your calculator. So this is up 1.5 and then still right and left 1. So I'm going to move to the right 1 and up 1.5. So here's half and here's 1. 1.5. Move it to the left 1 and then up half and then the whole 1. Then we're going to do it with 5. So 5 times 1/2 over 1. What's half of 5? 2.5. So up 2.5 and right and left 1. So to the right 1 and up 1, 2.5. To the left 1 and up 1, 2.5. That's how I'm going to get my parabola to be wider or fatter than my original. Any questions over that? Okay. Now we want to know what a value for W, find a value for W that will give the function the indicated number of x-intercepts. So what I have here is x squared plus W. What is that W going to do to my graph? Move it up, down, right, left, stretch it or shrink it. What is the W going to do? What if I plug in a number for W, is that going to move my graph up, down, right, left, stretch it or shrink it? Is it in the parentheses though?
Oh, no, that's going to go up.
Up or down, okay? That W is going to change the Y value because it's outside the parentheses. If it was inside the parentheses, it would move it left and right. Does that make sense? So it's going, right now it's a plus W, but we can change it and plug in a negative W. So if I graph this, we're going to graph just the parent function. You don't need to graph this because we're going to fix it. What is a number for the W that'll make my parabola have 2 x-intercepts, cross the x-axis twice? Who said something? Negative. Any negative, right? If I just shift my whole parabola down, I'll have 2 x-intercepts, correct? What if I moved it up? Would it have any x-intercepts? No, so I have to shift it down. Now I have 2 x-intercepts. And it could truly be any negative number for that. So W, in this case we have -3, but any negative value. Any questions over that? Okay, let's do the next one. What value for W would I need to make my parabola have only 1 x-intercept? How many x-intercepts does it have right now? 1. If I moved it up, would it have any? If I moved it down, would it have just 1? No. So where does it need to be? Right at the 0, right? So W has to be 0 for it to have only 1 x-intercept. Does that make sense? Okay. Last one is a negative x squared. What does that negative tell me? It's facing down. My parabola should face down. So my parabola is going to look like this, but what would I need to add to it to have it have 0 x-intercepts? Where would it need to go? Down. So what value would there be? Doesn't matter, just any kind of negative number, right? Yes. Why? Let me lasso it again. If I made it a positive, would I have 0 x-intercepts? If I had it 0, would it have would have 0 x-intercepts? It would have 1 at 0, right? But if I moved it down, it won't have any. So W just needs to be, in this case, I think it was -4. But again, any negative number. Any questions over that? Okay, let's go to the last ones. Also in your homework, you guys are going to be asked to describe the transformations. So those transformations came from all of this. Shh. Okay, the reflections, the stretch, the shrink, the up, down, and right and left. Okay, so that's all we're going to do here is describe those transformations that occurred. So that too. Can somebody tell me what that would do? It stretches it. It's greater, the A value is greater than 1, so it's a stretch. What about the 3, the -3? Not the 3 tells me that it's going to move to the right. Oh, the next one, yeah. Not that, we're still on the M. To the right 3. What about the 1? +1 tells me what? Up 1. Okay. The next one, we have a negative. What does the negative tell me? Reflects. Across the x-axis. What does the 3 tell me, class? Still a stretch. It's still greater than 1. So it's a stretch. -4, class? Right. 4. And the -2? Down 2. Okay, what does the 1/2 tell me here? It shrinks. The -5 is right 5. And the +4, up 4. Okay, your homework is the next 2 pages in your packet. Make sure you're checking it's 3-3.